Okay, now come to mathematical induction. Okay, so this actually mathematical induction is actually related to some proving some statement, and that statement is related to natural number. Understand? That statement is related to natural number, and you need to prove. So uh, what is the basic theory behind this? For a given statement involving for a given statement involving a natural number, let it for a natural number n, for a given statement, let's suppose there is one statement is given, and that statement involve one natural number, and that is n. If we can show that first one, the statement is true for n is equal to n naught. Take any natural number, that is n naught, and you have to determine whether the statement is true or false. Okay, so if the statement is true for n is equal to n net, and second, the statement is true for n is equal to k plus 1, n is equal to k plus 1, assuming that the statement is true for n is equal to k, where k greater than equal to n naught. Okay, so first of all, take any natural number, that is n naught, then put it in the statement put karo, then find it out whether it's true or false. If it is true, then go to next step. Then you have to assume statement is true for n is equal to k. Then you have to determine whether the statement is true for n is equal to k plus 1. If it is true for n is equal to k plus 1, then the statement is true. Okay, so here at the bottom you can write, then we can conclude that the statement is true for all natural numbers n greater than equal to n naught. Remember this one, n greater than equal to n naught is given. Okay, so let's suppose this is a line I am drawing, natural number, start from let's suppose 0, yada 1 2 3 and so on. Let's suppose you take n naught is equal to 2, and there is any kind of statement, let's suppose p. If this particular statement p is true for n naught, that is equal to 2, then you assume that this particular statement is true for n is equal to k, that is pk is true. I may call it subscript like p0 is true, sorry, here I have to write down p2 is true, this one. Then you have to assume that pk is true. Then you have to find it out whether pk plus 1 is true or not. If it is true, then this particular statement p is true for all the natural number, and the natural number is greater than equal to kete 2. माने ए आडू सब जते भी एलिमेंट थिबे जते भी नंबर अछि तांको पे 2. Which statement is p? The last one is written like this, n greater than equal to n naught. है पछ मान को पे कोन हे पारे, false भी हे पारे. It may be false for the numbers which are present to the left of this 2 or n naught. Okay, come to one question, directly come to one question. Show that 2n plus 1 is odd. So that 2 plus 1 is odd where n equals to natural numbers. using mathematical induction. ହେଲା? Okay, how do you prove this one? You must have done this one in grad level, graduation, in plus 2 level. You must have studied. Do it. Okay, so let me solve this one. Then you solve next question. Okay, so let n not is equal to, let's suppose I take 1. Hello? Or let me write it down like this. Let Pn, this is the statement. Pn is equal to how much? 2n plus 1 is odd. This is the statement. We need to prove this one for the set of natural number, where n belongs to the set of natural number. Step 1, you have to do stepwise, okay? Step 1, let n is equal to, okay, let n is equal to nearly 0. This is nothing but the n naught. Or let's go I write n naught like this. N naught is equal to 1. Then Pn naught কেতে হবো? 2 into 1 plus 1, that is equal to 3, which is odd, which implies P1 is true. n naught জায়গায় 1 লিখে দেব, P1 is true. Step 2, let us assume that Pk is true. Let us assume that Pk is true. तापर तुम प्रूव करिवो थर्ड स्टेप रे Pk plus 1 पे तुम कोन लिखिबे ठी Pk कोन हबो n जगह रे यू हैव टू पुट द k 2k plus 1 is odd होगा नहीं which implies 2k plus 1 can be written as 2 into t plus 1 like this. Odd number कौन हुए 2 into t plus 1 हैला have written like this 2t plus 1 where t belongs to sudden natural number. Now come to step 3. Let us prove for pk plus 1. What is pk plus 1? 2 into k plus 1 plus 1 equal to, just open the bracket, 2k plus 1 में add नहीं गली. In the previous here, what is 2k plus 1? Give to equation 1. 2t plus 1. What are you going to do? In this particular equation, see here, in this equation, 2k plus 1 को केमते लिखा है 2t plus 1. Okay, so here we write down 2t plus 1 plus 2. এই জায়গায় মু কোন লিখলি 2t plus 1 from equation 1. Hala, wrote it down like this. Then 2t plus 2 को गोटे जगह लिखिबो, एटा हला मु लिखिली 1. Take 2 is a common, t plus 2 1. Then we can write 2m plus, sorry, you can write it down as 2m plus 1 where m is equal to t plus 1. You know that any number if it is written in the form of 2 into something plus 1, it's an odd number, which implies pk plus 1 is true. Okay, you may write it down here, which is an odd number. which is an odd number. Hala na? Which implies pk plus 1 is hala. Then what do you write down finally? Final answer by mathematical induction. By mathematical induction, Pn is true. That we need to find it. Pn is true. First statement thila na Pn I have written here. Hela, what is written here? Pn. Pn re kon achi? 2n plus 1 is an odd number. So we proved it by using mathematical induction. Question number 2. Question number 2 is so that one plus two square two cube so we need to prove this one. 1 plus 2 square plus 2 cube plus and so on. Can you do this one? Okay, so what do you write? You write it down Pn first. Pn is how much? 1 plus 2 square plus 2 cube and so on. Minus 2. This can be written as, this Pn once again can be written as 2 to the power 0, 2 to the power 1, 2 square. Is it correct? Yes, it's correct. Step 1. Let n is equal to 1. After let n is equal to 1, find out left hand side, LHS. This kind of question you have to find LHS and right hand side. The previous question no need to find LHS. That is LHS no thila na RHS no thila. Ei beti koro. LHS kete hobo? N jaga re 1 put koro. So this term. Hala kete hobo? 2 to the power 0 plus 2 to the power 1 is equal to 3. RHS. Edi put koro. 1 put koro n jaga re. 4 minus 1. Which implies LHS is equal to RHS, which implies P1 is true. Hala. Step 2. Let PK is true. So write down PK. PK kemti hobo? Is equal to 2 to the power k plus 1 minus 1. Is it correct? Yeah. 2 to the power k plus 1 minus 1. So it's equation 1. Step 3. Let us, we need to prove from P k plus 1. Hala, we need to prove from P k plus 1. So P k plus 1 kete hobo? 2 to the power 0, 1, okay, this is the pk plus 1. Okay, so here we can write it down. Right hand side re kete hobo? This is the right hand side. Hala, understood? K jaga re k plus 1 put kare. तुमे एबे लेफ्ट हैंड साइड नबो. लेफ्ट हैंड साइड नु तुमे बाहर करिबो राइट हैंड साइड. From left hand side you find it the right hand side. So this is 2 to the power 0 to the 1. What is the previous term of this? Previous term 2k plus 1. Previous term of 2k plus 1 is 2 to the power k. गोटे कमी जीव ना पावर रे हैला okay this is already you have calculated in the equation 1 what is there na अच्छे कि नहीं so 2 to the power k plus 1 minus 1 plus लिखी देबो from 1 solve it you will find it out this होगा कि नहीं देखो तो होची कि नहीं there are 2k plus 1 there are 2k plus 1 are there 2 to the power 2k plus 1 दीटा अच्छे कि नहीं देखो ये गोटे अच्छी ये गोटे अच्छी एगो मैं दी मल्टीप्लाई कर देली 2 into 2 to the power k plus 1 हैला एटा पावर केते अछि ठी 1 अछि ऐड हे जो पावर टा so 2 to the power k plus 1 plus 1 हैला minus 1 that is it this is हैला that is equal to RHS okay now in the last one you write it down pk plus 1 is 2 हैला ओके नोट तो मतलब पाई जीवटा जो छाड़ के तब लिखि दो हैला hence by mathematical induction what is true pn is done